Okay, so now we're really ready to get into the meat of the matter here. So we know what an interpretation is, and recall what that means, okay? We have a domain for our quantifiers to go over, and that involves all the names and variables of our formulas. For each we have a truth value for every sentence letter that might appear, and those are the things from TFL. We have names assigned to everything in the names. I shouldn't say everything, but everything that's a name is assigned to something in the domain. There might be things in the domain that aren't assigned. It's fine. And for each predicate other than equals, which we'll treat in this section specially, we know what's true and what's not true, and that's an interpretation. So truth in first-order logic is based on interpretations. Just like in TFL, semantic questions were always dependent on valuations. Okay, so from earlier we know there's three kinds of sentences in first-order logic. We have atomic sentences. We have sentences whose main logical operator is a connective, so an or, a not, an implies, a biconditional, and sentences whose main logical operator is a quantifier. So, when we were building up sentences in the previous lecture, those are the three things that could have happened, and we need to talk about how you compute truth with them. Luckily, all of our intuition from propositional logic basically carries over. So, these things are going to be true based on the interpretation directly. These things are going to be true based essentially on thinking about TFL. And then these things are going to be true with a little bit more thinking about what a quantifier is supposed to, represent. Okay, so here's an example. So your domain is all people born before the year 2000, and that includes me. It may or may not include you, but here's a couple names in that domain. So Aristotle and Beyonce. We have P of X, that X is a philosopher, and an R of XY, that X was born before Y. And they say this will be our go-to example. Okay, so we'll keep this in mind. Maybe I'll make it a picture, and we'll open that picture up so we can refer to it as needed. Okay, so atomic sentences. So the truth of atomic sentence, like I said, is straightforward. When we defined an interpretation, we're kind of taking care of all these already. So let's see. The interpretation specifies if it is true or false. It's exactly what I just said. So given our go-to interpretation, P of A is true if and only if Aristotle is a philosopher. Well, he was, okay? So the sentence is true. And B of P of B is false. Now, maybe you could argue that Beyonce is a philosopher, but I would say most people would consider her an artist, not a philosopher, so we will say that P of B is false. RAB is true. Is that the case? Aristotle was born before Beyonce? Yes. And RBA is false, and RAA is false. You could not say that Aristotle was born before Aristotle. It just makes sense, okay? So, that's how we handle atomic sentences. They're basically based on the interpretation, nothing else. So they give this definition, and again, they're using the cursive letters because we're talking in the meta language right now. So this nth place predicate is true in a given interpretation. So until you decide on your interpretation, truth is not in the picture. Okay, it means that R is true of all these objects in that interpretation. I mean, that is the easiest definition it could be, and that's what it has to be, right? That there's no other option, and the order matters, right? Because of this two-place predicate, born before, the order matters. Okay, in one way it's true, and the other way it's false. Now they say equality is special, so we have to treat it specially. A equals B is true in a particular interpretation, if and only if they name the same object. So remember, In an interpretation, in that definition we had, when we defined an interpretation, we had to give every name that we're going to use has to be assigned to something in the domain. And that assignment is what we're referring to when we're talking about equality here. Okay, so you and someone else may have different interpretations in that this first person might take the letter A to refer to person X, and this other person might take the letter A to refer to person Y. You may have different truth values in your interpretations in that case. But once you agree on an interpretation, there should be no disagreement about the truth of equality, okay? Or really any truth of anything, because at that point everyone's sort of on the same page. So this is one of the things that in politics is why politics is not logical quite often, because interpretations are so varied among all kinds of things. The interpretation of a certain word matters a lot in politics. And so, if you have two people arguing politics, there's no point in this argument unless you start coming to an agreement of what words mean and things like that. So, in my, if I'm arguing politics with someone, I always come back to, okay, what does this word mean to you? And what way are you using it? Okay, because it's fine and dandy to say this and that person is a horrible person, and this other person could say, well, no, they're great. But if your criteria for horrible and your criteria for great are different, well, obviously you're going to have different opinions, right? You're going to have different things you consider true. And in a day and age like now where you're bombarded with media from all kinds of biased sources, this ability to come to consensus, at least on a basis of a language to speak in terms of, is more important than ever, right? So, this stuff kind of gives you some perspective on a lot of things in society. So, sentential connective. So, we, as far as, understanding what atomic sentences are true in a given interpretation, it just comes directly from the interpretation, nothing else. What about connectives? So if I have, an interpretation, then I know that I can find any predicate is true or false. Fine. What if I had an and of two of them or so on? Well, this is where our intuition from TFL comes in. Okay. So if I have, if I had RA and RB, or sorry, PA and PB from earlier. PA would be true, PB would be false. So if I took PA and PB, well, I would need, both it'd be false, right? Because it's an and for an and, both things have to be true to be true. Or it not implies if and only if all work the same as before, except now we're couching it in terms of an interpretation, and we are you have to go back to the interpretation at all times in order to determine semantic questions of truth and false. True and false. So they look at some examples in terms of their go-to interpretation. So they say A equals A and PA. Now, you can't, okay, I read it a little weird. It's A equals A and PA, okay? Now, why is that true? Well, A equals A is true because in our interpretation, A is referring to Aristotle, and as long as the name in here is referring to the same object in the domain, that is this list of people born before the year 2000, then equality is going to be true, as from what we said earlier. P of A is true because Aristotle was a philosopher. Okay. Now, the second one, RAB. RAB means Aristotle was born before Beyonce. That's true. We said this earlier. But we also said that we're going to have the interpretation that P of B is false. We're going to assume that Beyonce is not a philosopher here in our interpretation. And so the and of these two things is false because this one was true, this one was false, so the and is false, just like TFL. And you can go through the rest of these as you like. This one's interesting. A equals B is false, right? because A is referring to the object in the domain called Aristotle, B is the object in the domain called Beyonce, and it's, that equality is false. They're not equal. But to say that they're not equal, well, that's true, because, it swaps the truth value of the sentence. My advice is to go through the rest of these and just make sure you understand which ones are true and which ones are false. They're all pretty straightforward. No problem. Okay, so that handles connectives, okay? So, all the work we've done to this point in the class through TFL, it's all sort of right in there. So the remaining question in first order logic is, how do we do semantics with quantifiers? Well, what we call the quantifiers kind of gives it away, right? So for all x fx, if f is some predicate, it means, no matter what thing in your domain you pick, that predicate's true of everything in the domain. Because the interpretation tells you what's true. Now they say this is not general enough, so we have to be a little careful with that, but that basic idea is gonna work. They go through some examples. Let's just jump to the definition down here. Well, actually, maybe we should read through this. So we want to say for all x there exists y, lxy is true, just in the case that there exists y, lxy is true of everything. Okay. Now, they say this is problematic because our interpretation does not directly specify what this is to be true of. Whether or not this is true of something should follow just from the interpretation. And so it's kind of saying that this naive idea is not working, basically because having an interpretation isn't conducive easily to computing this in some sense. Okay. Okay. I think you should just read through this carefully. I think me reading it to you isn't going to be super useful. But let's look at this this example. In our go-to interpretation, there exists x rbx. So it'd be there exists x, that x Beyonce was born before x should be true, because there are people in that domain born before Beyonce was born. And they say, for example, Lady Gaga is one of these people. And if we were to let C refer to Lady Gaga, then RBC would be true, and that would suffice to make exists x RBX to be true. So, okay, fine. So, okay, then they talk with a few more examples. Okay, you should just read them. So they say, okay, we need to give a precise definition. Now, in every logic class, this ends up being somewhat ugly, okay? And this one is no different, and they even say this here. So let's just sort of look at what they define. So they say, if A is a formula, and X is a variable, and X is free in A. So they're going to write, this in that situation. If it's a formula and you have a free variable X, they'll write this. And if C is a name, so this would be not a variable but a name, they're going to write this for the formula obtained by replacing every occurrence of X with C. So they have free variables, they're going to plug C in for those free variables. They call that substitution, okay? For all X and there exists X. And C is the what's called instantationing name. That's a hard word to say. So here's an example. So this thing, there exists X, R, EX, if and only if FX. Well, there's a variable in here, X, and that's variable is a bound variable to bound to this quantifier. There is a name in there, E. And they're saying this is a substitution instance of this sentence. Now you can interpret this as saying, from this, you can start sort of at this sentence and say, well, for all Y, I can pick anything in my domain for y, and I'm going to plug it in for that value y and get this sentence. So here they've taken this thing and they've replaced y with e, and they can do that. They can do that with anything because it's a for all. Okay. So that's what they mean by this. They say instantiating the name e. The instantiating name is e. So the name that was replaced when removing a quantifier is called the instantiating name, and the variable that was instantiated was y. The thing that was replaced was y. Now, the interpretation, when we specify interpretation, we give all the names. Okay, so in this interpretation for this example, we said lowercase a and lowercase b. Those were the only names we could use. Okay, and they say take any object in the domain and a name c which is not already assigned. If our interpretation is I, then we can consider an interpretation I, and then they write this slash in here, ID/C. Now, D is an element of the domain. It is not a name. Okay, C is a name, so they're putting this slash in here to sort of assign a variable after we've sort of done an interpretation. So why is this allowed? Okay, sometimes when you're writing a proof, you come to a point where you want to get rid of a for all, for example, and you want to reach into the domain and you want to replace it with some name. Well, if you don't know that you're going to do that in advance, you're not going to make that a part of your interpretation. You need to be able to assign things later. So, which is just like I, except it also assigns the name C to the object D. So this notation is a modified interpretation. Okay, so it takes the original interpretation and it adds one more named object to it. Okay, so in fact it is a different interpretation, but we're kind of saying, well, it's like I, but a little bit augmented, a little bit upgraded. We can say that D satisfies the formula this in the interpretation I, if and only if this thing is true in this interpretation. So this is the meat of the matter here. We are now talking about two different interpretations at the same time. And that's why this is kind of ugly. But we're saying that D satisfies this formula, meaning I can plug D, the name, in for the variable x, if and only if I, D is not a name, it's a domain element. It's my mistake. Domain element satisfies this formula in the interpretation I, if and only if I can make an upgraded interpretation where D is interpreted with the name C and plugged in. That's a mouthful, but I guess they summarize it in the box. So they say this interpretation is just like I, except you give one more assignment. So you're putting one more thing in this list. Then this object D satisfies this formula in I, if and only if this thing is true in the upgraded interpretation. Whew, that's a lot. It's kind of weird, but this is the kind of thing where a definition is complicated, but doing it in practice is simple. Okay, so they're going back to their interpretation here. So they're saying this interpretation, this augmented interpretation, is all this stuff down here. So you take the original interpretation, this is capital I, bold I, and you're now looking at this interpretation, Socrates/C. So they're letting now the name C refer to Socrates. So the sentence, for all x, ax is true in I, if and only if for any object D, this is true in the upgraded interpretation. Again, this is kind of complicated, but let's look at the definitions. Let's make it very clear. For all x, a with x as a free variable, well, I guess it's a bound variable once it's inside this quantifier. This is true in interpretation. So true in our given interpretation if every object in the domain satisfies this. Okay, that's what you want it to mean. And there exists X is true in interpretation if there's at least one object that satisfies this. And they're very clear that this is a pedantic thing, okay? But they want to be correct, okay? So, but the important thing is, you know, they have come up with a way to formalize our intuitive notions of for all, and there exists. And if you, as long as you come out of this understanding what's going on right there, you're going to be okay. All right? They were right that it's ugly. It's not intuitive to write it down that way, but it's okay. So they say, for instance, Socrates, Plato satisfies RxY. RxY being was born before, because it's true in some interpretation. That, you know, when we say Socrates and Plato, we're referring to the historical figures here. So I think this lecture probably is a little confusing by the end, but I think that's just a function of the material sort of being a little complicated at this point. But I think the examples I work out will make it a little more clear. For example, here's a problem where they give us an interpretation. They ask if these things are true. Okay. They give us a diagram for an interpretation and so on, and they ask, are these things true? Your intuitive idea of for all meaning for all things in the domain, and exist meaning there's one thing, at least one thing in the domain, if you work with that, you'll be okay. All right? So that's all I got for this chapter.